Good morning, everyone. I hope you all had a fantastic weekend, and make sure that if you did not submit the work from Friday or the day before Thursday, make sure you go on and do that big ideas on the similar triangles and submit the worksheet on Classroom. Just take a picture of it and submit it if you did not. Okay. Today we're going to just have some short notes on the triangle proportionality theorems. So I'm going to go through them quickly. You can pause it, you can stop it. If you have any questions, feel free to play it back, and then I'll be happy to answer anything over email or when I get back. Okay. So the triangle proportionality theorem, there are two parts to it. So the first one says, triangle proportionality theorem says if a line parallel to one side of a triangle, so in this case, that line would be DE, is parallel to AC, or that segment, then it divides the segment into segments of proportional lengths. So what does that mean? It divides the sides, I should say. So if DE is parallel to AC, that means that these two pieces are going to be proportional, and these two pieces being AC are going to be proportional. So we say if DE is parallel to AC, then we can say that BD over DA is equal to BE over EC. So we no longer really have to do like part over whole. We could just say, okay, the top over the bottom, top over the bottom. Okay. The converse, remember, converse is kind of like the reverse. It's in the opposite order. So we just say if BD over DA is equal to BE over EC, then that means those two pieces, DE and AC, are parallel to one another. Remember, it's kind of like the reverse. So it kind of goes in the backwards direction. So as always, we're going to do some examples. What I'm going to do is I'm going to work out the check-ins so that you can see them. I'll pause and work them out, and then you'll have them worked out on here so you can check them. So find the value for x. So we have that these two pieces are parallel. Okay, the segment in the middle is parallel to the third side of the triangle. So what that does is that creates the sides. It's going to cut the sides into proportional pieces. So it's going to cut this side into two proportional pieces, and it's going to cut this side into two proportional pieces. So we would say 12 over 14 equals 15 over x. And we can cross multiply. And when we cross multiply, we get 12x is equal to 210. And so x would be equal to 17.5. Side note, this would also work if you do 12 over 15 equals 14 over x. The triangle proportionality theorem says you have to do the sides of the segment. So 12 over 14 equals 15 over x. Ooh. So that's why we do it that way. Okay, same thing with example 2. So first off, we need the pieces of the side. So we see that these two, this segment in the middle is parallel to the third side. So we could say part of the segment over the other piece of the segment. So this piece over this piece is equal to this piece over this piece. But first we need to figure out what this top missing piece is. So if the whole thing's 55 and the bottom's 45, this piece is just 10. And now we can set up our proportion. So 10 over 45. So the top over the bottom piece equals the top over the bottom piece, x over 36. And you can cross multiply same way. You're going to get 360. 10 times 36, 360 equals 45x. Solve for x. So x is just going to equal 8. Okay. Now remember, you can check yourself by putting in 8 here. And if you do, you'll see you can always do your proportions like the last time, which you could do 8 over the whole thing. Does that equal 10 over 55? And you can see if those scale factors, those proportions are the same. Okay. One more example before I fill in the check-ins. So example 3 says find the value of x. So now we have a little bit of expression here, but we're going to treat it the same way. We see that these two segments are parallel. So that means that 30 over x plus 7 is going to equal 25 over 15. And we can cross multiply and solve. Just make sure, so we're going to do 30 times 15, and when we do that, we're going to get 450 equals, when you do 25 times x plus 7, you need to make sure that you put the x plus 7 in parentheses and that you distribute. So you're going to get 450 equals 25x plus, and then that'll end up giving me 175. Subtract 175 from both sides, solve for x, and you will get that x will equal 11. Okay, so what I'm going to do now is I'm going to fill in the check-ins so that you can check your work as you fill out your notes packet. So yes, you can check yourself in your notes packet. In your notes, I forgot to mention in the beginning, this is those 8.4 notes. I'll put it in Google Classroom. It's attached that note packet that I gave you back on last Monday. Okay, so it's 8.1, 8.4 notes. So this is 8.4. You can go and fill them in. So what I did was I filled in the check-ins on here. So check-in number 1, you'll see that we did x over 18 equals 56 over 21. We solved. We got x equals 48. So you can check that. You can pause it to check yourself. Check-in number 2, we did the same thing. X over 7 equals 21 over 6. How did I get the 21? We want to do the 27 minus 6. That means we'll be left with 21. We don't want the whole thing here because we're just doing piece over piece. And then our last check-in number 3 is 6 over 21. So piece over piece equals x minus 1 over 3x plus 1. And once we set that up, we can cross multiply and solve. Just make sure you are using parentheses when you do the 6 times the 3x plus 1 and the 21 times the x minus 1. And what I'll do is I'll extend the page a little bit and keep this up for a second because I know the smart notes symbols in the way. Okay, and you'll end up distributing and solving for x and you get x equals 9. So again, piece over piece equals piece over piece as long as the one segment is parallel to the third side. Okay, so now what you can do is you can flip your page over and we're going to kind of talk about when the proportionality theorem won't work. So using the converse. So the contrapositive of the triangle proportionality theorem basically says that if the two pieces, say for example this one, if the two pieces, when you divide them, they're not equal to the other two pieces divided, then that means those segments, maybe in the middle like MN and JL, they're not going to be parallel. Okay, the inverse then says if TU is not parallel to QS, then you know that those proportions are not going to be true, which if you think about it really makes sense. So let's look at some examples to clear this up a little bit. So it basically is asking, is MN, so is this segment right here, parallel to JL? So to check that, we're going to do exactly what we did in the last ones, and we're going to see, are those proportions, piece over piece, does equal piece over piece on the right side? So we're going to see, does 11 over 15.4 equal 10 over 14? If it does, then they're parallel, MN and JL. If it doesn't, then they're not parallel, and it's really that simple. So these are ones you want your calculator for. 11 divided by 15.4 is just equal to 0.714. And we want to know, is that equal to 10 divided by 14? If you do 10 divided by 14 in your calculator, you'll get 0.714. So yes, those two sides are proportional, their pieces are proportional, so therefore that means that MN must be parallel to JL. Okay, so now we know that those two are parallel, so yes, they are. So for the check-in here, just kind of further reiterate this, is PS parallel to QR? So we want to know, are these two segments, PS and QR, parallel to one another? Well, let's check the proportions. So we're going to see, does 90 over 50, does the top pieces equal the bottom pieces? 72 over 40. And I'm just going to put the fraction in my calculator. So 90 over 50 is about 1.8. We want to know, does that equal 72 divided by 40, which is also 1.8? So yes, they're equal, which means yes, PS is indeed parallel to QR. Okay, so this is using the converse, what we saw on the other side. So proving that those segments are parallel to one another. And again, if this was say 80 over 50 and this one was 72 over 40, it would not be equal. So no, they're not parallel. It's that simple. But since they are, PS is parallel to QR. So last thing we're going to do is we are going to do a little bit of application, a little word problem. So it says on the shear ax shown, BA, so I'm going to label it, BA is 33 centimeters, CB is 27 centimeters, CD is 44 centimeters, and DE is 25 centimeters. So I filled it all in. Yes, you can see it is a triangle. Explain why the shelf is not parallel to the floor. So BD is kind of like my shelf here. That's what they're talking about. And they want to know, is it parallel? Or they're saying, why is it not parallel to the floor, which is AE? So the best way to prove that they are not parallel is to simply set up a proportion. So we would say, let's look at this left side over here. We want to know, is 27 over 33, is that equal to the right side pieces, which is 44 over 25? So we're going to simplify 27 over 33 and we get 0.818. And we want to know, is that equal to 44 over 25? 44 over 25 is 1.76. So are they equal? They are not equal. So what does that mean? So that means BD is not parallel to AE, which they told us we were proving that. And this is by the contrapositive of the triangle proportionality theorem. No, I'm not going to make you list the contrapositive out of your head on a test, but it is good to know. Okay, so what is the most important thing to take out of this lesson? Well, in order for the triangle proportionality theorem to work, so like piece over piece equals piece over piece rather than part over whole, those two, that one side has to be parallel to the third side. Okay, it will not work if it is not. So what you're going to do now is read the post on Google Classroom. Remember, you can pause this and play this back at any time. You can email me or send me a remind with any questions or put a question up on the Google Classroom post. If you want to make it private, that is fine. And I will do my best to get back to you and explain to you what is going on. Okay, but otherwise go back to the Google Classroom post, see if there's an assignment posted on there. If you have anything, feel free to contact me, and I can't wait to be back in with you all. Have a great day, everybody.